Good morning students. I am Dr. Kavitha, Professor Department of Physics, Dr. MGR Educational Research Institute. Today's class I am going to take Cyclotron from Nuclear Physics for second BSc Physics. First you must know what is a cyclotron. A cyclotron is a specific kind of particle accelerator that can accelerate the charged particles to very high velocities. The charged particles from the cyclotron can be used to bombard into target nucleus to induce nuclear reactions. Construction of a cyclotron. A cyclotron consists of two hollow semicircular metallic boxes D1 and D2 called Ds. Second one, source of ions is located near the midpoint of the gap between the Ds. Third one, the pole pieces of strong electromagnets are placed between the whole apparatus. The fourth one, the whole setup is placed inside the vacuum chamber. This is the figure for this cyclotron. Here you can see the vacuum chamber. This is ion source, electric field region. This is a beam coming from this bottom end, and here is target. Here is a magnetic field supplied in this region, and here are the Ds. Principle of cyclotron. The cyclotron works on the principle of Lorentz force. The Lorentz force means the force experienced by the charged particle due to the electric and magnetic field. Working of the cyclotron. The source of ions placed at the midpoint of the gap between the metallic boxes experiences a high frequency of electric field, so it is accelerated and move on from D1 to D2. Then after it reaches the region of magnetic field, the direction of path of the particle changes to be semicircular due to the effect of the strong magnetic field. Now, due to the high potential difference maintained between D1 and D2, the charge of the Ds changes and the particle continues to move in a circular path. Due to the continuous acceleration of the same particle by electric and magnetic field, it reaches the high velocity with increase in radius. Finally, the particle is made to hit the target by the help of the directed deflecting plate. Now, the derivations are given here. mv square by 2, that is centripetal force, is equal to Lorentz force, qvb. Then if you are cancelling v and v here, then finally we get v is equal to r into qb by m. And if you take this qb by m as a constant, we can have v is directly proportional to r. Force is equal to qb by 2 pi m. Now frequency of oscillation f is equal to 1 by t, therefore t is equal to 2 pi m by qb. Kinetic energy is a half mv square. So finally we got kinetic energy is equal to half r square q square b square by m. Limitations of the cyclotron. The energies to which the particles can be accelerated in a cyclotron are limited. Field variation. The frequency of the ion can be kept constant by increasing the magnetic field, and at such a rate the product remains constant. This type of machine in which the frequency of the electric field is kept constant and magnetic field is varied is called synchrotron. Frequency modulation. In another form of apparatus, the frequency of the applied AC voltage is varied. This type of machine in which the magnetic field is kept constant and the frequency of the applied electric field is varied is called frequency modulated cyclotron or synchrocyclotron. Thank you. If you are having any doubt, please ask me.